Hello and welcome, dear friends. In this video we'll continue to talk about the Lerp methods. In particular, we'll talk about how the Lerp method works with vectors and quaternions. Without further ado, let's get started. Okay, we have three objects. The small smiley face will move smoothly between the 2 points. First, let me hit the play button just to show how the Vector.Lerp method works. The movement speed slows down as the small smiley face gets closer to the large one. The smile object has the linear Lerp script on it. Other objects called left endpoint and right endpoint are objects of image type. They don't have any special behavior, they're just image objects. Okay, open the script, let's see. The syntax of the Lerp method looks like this. The method has 2 parameters of vector type. I'm gonna move an object in 2-dimensional plane, therefore I have used vector2 type. 2 variables of transform type will give coordinates of the left endpoint and the right endpoint, respectively. And 2 variables of vector2 type become arguments passed to the Lerp methods. The current position will store the coordinates of the moving smile object. The target position will store coordinates of one of the end points, depending on the direction of movements. The Lerp value is limited by the interval from 0 to 1. This is almost the same as what we did before, but I have used the vector2 type instead of the float numbers. Very simple. Let me assign coordinates to the current and target positions. I will do it inside the start method, respectively. Now let's look at the update method. Remember that Lerp is a linear interpolation. Even if you use the vector3 type, the movement will be linear. Just in this case, the Lerp method calculates each coordinate separately, but using the same formula. This formula is a special case of interpolation and nothing else. On the flip side, this particular case can be used to model the behavior of a wide variety of objects. We have a very simple object, but let's get back to the update methods. We can do the same here. We constantly update the current coordinates of the object by adding a value returned by the Lerp methods. The Lerp value replaces the t variable, and then I am assigning the value of the current position variable to the coordinates of the object. We need to take into account that the target object will change. When the object reaches the right point, it will change the direction of movement. To do this, I have created the change direction methods. This time I decided to check the x coordinates, so the first if statement checks if the object is very close to the target. The absolute value excludes the negative result of the subtraction. And if the object is very close to the target position, the method identifies whether the smile object must turn right or left. If the target position is the right point, then the comparison will return the true value, and I need to assign the left point object to the target position field. If the comparison returns the false value, it means that the current target position is the left point object, and I need to assign the right point object to the target position fields. If you are confused by the ternary operator, the same behavior can be created using an else-if statement. I believe it is simplified as much as possible. Okay, let's check it out one more time. Make sure you have dragged objects to the corresponding fields. Click on the play button. Good. The Lerp method works as expected. I can change the coordinates of the target objects. Everything will work fine. Let's see. Okay, great. If you don't like linear functions, I will show you how to move an object along a curve. Let me enable one more object. It's gonna be the control point. Let me replace the script with the curve script and add the end points and the control point to the fields. Unity shows the green curve. If I hit the play button, the smile object will move along the curve, changing the direction when it reaches one of the target positions. Okay, let's open the curve script. Let's discuss its members line by line. This time I have 3 objects of transform type. These fields store both endpoints and the control point. The lerp value is not clamped to any range, but I'm gonna check its value once per frame. I have declared 3 variables of Vector.2 type. 2 of them store the coordinates of the endpoints. I will use them to change the direction of movement. The current position stores the current coordinates of the smile objects. This time I will update the value of the lerp value variable in another way. The speed variable will affect the speed of movements, and the start method initializes all vectors we have declared. The left endpoint is for the current position and the starting position, and the first target position will be the right endpoint. Let's take a look at the update method. I have created a method that updates coordinates for the smile object. It has 4 parameters and looks very scary, but actually it's very simple. I have just used the formula of the quadratic function. It is not an ordinary quadratic function. This kind of curve is also called the Bezier curve. The coefficients of the quadratic function also obey a special rule, but in fact this is a special case of a quadratic function. Unity calculates new coordinates according to this function and updates the position of the smile object. Don't focus on the formula, we can use the formula of any quadratic function here. It doesn't have to be the Bezier curve, but in that case we have to find coefficients of the quadratic function, which is not always easy. The update method changes the value of the t parameter once per frame. When this happens, the method calculates new coordinates according to this formula and the value of the t parameter. To update the value of the lerp variable, I just multiply the speed by time delta time and add the result to the lerp variable. The value of the lerp variable increases. As a result, the object moves. The change direction method checks if it's time to turn in the opposite direction. The beauty of the Bezier curve is that the object reaches the endpoint when the t parameter becomes equal to 1. So when the t parameter is 1, the smile object must turn in the opposite direction. To make the object move towards the opposite target position, I need to update the value of the lerp variable. This time I have used the else-if statement. It is not the best decision, but I hope it is more readable. So depending on the current target position, the else-if statement replaces it with the opposite target position. If the current target position is the right point object, the method replaces it with the left point object, and vice versa. If the current target is the left point object, the method replaces it with the right point object. Since the transform position is of Vector3 type, I have converted it to Vector2 type to avoid the error. The onDraw gizmos method creates many small green circles according to the formula, just to visualize the path. The method doesn't affect the result, it just copies the formula of the Bezier curve. Okay, back to Unity, let me run the play mode one more time. Good, it works fine. I can move the target positions. In any case, the smile object will move along the curve. Okay, so far so good, but let's do something more serious. Let's see how the Lerp method works with quaternions. I have created another scene. It is a 3D project. Let me hit the play button and we see a fragment from a kind of a horror movie. A zombie stands under a light bulb and emerges from complete darkness. The light here moves unevenly, creating the effect of a light bulb. Okay, let's see what we have in this scene. First of all, it is zombie 3D objects. Let me show it. I'll turn on the directional light just to show the zombie objects. The zombie does nothing, it is just a prefab and nothing is interesting in it. Let me explain how to get this completely dark room. It's easy, I have modified some of the default settings. The background color of the main camera object should be set to black color. Projection is perspective and camera is looking at the zombie. To activate the lightning window, select Window, Rendering, and here it is. Let's take a look at the lightning window. Here we need to modify the environment default settings. Select the Environment tab and remove the skybox material. The skybox is the sky rendered by default. Let me show it. We don't need the skybox in this scene, so let me remove it, selecting None. And let me disable the directional lights. Well, there is no need for this object at all, since I have added another light object, but I haven't removed it just to show you the zombie prefab. The sun source is already disabled. It was the directional light object, and I need to modify the ambient color. Just make it black. I have decreased the value of the intensity multiplier. Its default value was 1, and that's it. We have a very dark room. Other properties have default values. Okay, back to the scene. There are 3 more objects in it. The spotlight is located above the zombie. It has the Vector.Lerp script in it. We're gonna talk about its members a bit later. And there are 2 empty game objects in the scene called left point and right point. Each empty object is at an angle to x-axis. These angles will restrict rotation. We don't really need these objects. I could have calculated the rotation angle without them, but okay, let them visualize what is happening here. The initial angle of the spotlight object is equal to the angle of the left point object. Well, very close to it. Okay, let's open the Vector.Lerp script. The left point and the right point fields store those empty game objects. Referring to these endpoints, I will get target angles. Okay, we have 2 fields of Quaternion type. Unity internally uses quaternions to represent all rotations. It is also a very interesting topic, but for another video. Now just note that the variables of Quaternion type help to solve any problems associated with the rotation of objects. The last field is the Lerp value. I guess there is no need to explain it one more time. I have initialized the current and target rotation variables inside the start method. The bulb will first turn to the right and then to the left. The Lerp method does pretty much the same. It is still the linear function that returns a value between a and b coefficients, but this time parameters are of Quaternion type, representing angles of the left endpoint and the right endpoint. The method is running every frame, and referring to the updated value returned by the Lerp method, I will change the rotation property of the spotlight objects. The change direction method replaces the target angle. I do not pass any arguments here, since all variables are class-scoped variables. We're gonna rotate the object by changing the x variable of the rotation property, so it is enough to check the value of the x variable. If the rotation angle is close to the rotation angle of the right object, Unity starts to rotate the light to the left, and vice versa. Let's see how it goes. Run the play mode, and good. We can add this scary moment to the game if we create a horror game. Understanding the Lerp methods is the first and the most important step to understanding Bezier curves. Note that the Lerp method is just a special case of a linear function and nothing else. I hope you found something useful in this video. Thanks for watching. See you in the upcoming video.